Good evening, everyone. I am Tanisha Tyagi from Eschan Publishing, and I welcome you all to the fourth session of Day 1 of the Mathematics Summit, second edition. I hope you all are having a great time and enjoying the sessions so far. In this session, we are diving into suggested pedagogies for teaching mathematics as per the National Curriculum Framework NCF 2023 presented by our esteemed speaker, Ms. Jaspreet Sethi. Ms. Sethi is the founder of Hatanoki Math with a Smile. She has a master's in mathematics education from Teachers College, Columbia University. She has served as the department chair for middle school mathematics at the Bushhaven Lennox School, New York, and on the advisory board for teacher education at Teachers College, Columbia University, New York. She is LETRS certified and has authored a series of children's books. With over 2 decades of experience in the field of education, Ms. Sethi has worked extensively with children and learners, consulted with schools, institutions, and government bodies, trained teachers and educators, and mentored parents and families in various domains and capacities ranging from making teaching and learning experiences more meaningful to student engagement, to classroom management, to effective instructional planning, to curriculum design, to providing tools and resources for holistic development of learner communities. Participants, just give us a minute. There's some technical error. Before we start, I would like to mention a few housekeeping rules. Participants will be muted throughout the entire session. Please ensure you have a pen and paper to note important information. The chat box will only be enabled during the Q&A round. And to receive your e-certificate, please fill out the feedback form that will be sent to your registered email ID after the summit. The lucky draw and quiz will take place tomorrow at the end of the summit, that is at 5 p.m. All the participants stand a chance to win Amazon vouchers worth rupees 40,000. So please don't miss any sessions. Now, without further ado, let's invite Ms. Jaspreet Sethi to share her insights. The floor is yours, ma'am.
Thank you, S. Chand, for the opportunity once again, and thank you, Tanisha, for the warm welcome. Before I begin, I just want to make sure that I'm audible, and I will be sharing my screen. I just want to make sure if it's visible to everyone.
Yes, ma'am, you're audible.
Awesome. Thank you so much. Hello, everyone. I'm here to discuss suggested pedagogies for teaching as per National Curriculum Framework 2023. And I will begin by clarifying some terminologies and then introduce you to some methods, some strategies, some practices, techniques, and principles that hopefully all participants pre-K through 12th grade will be catered and have something to take away. So I always begin when I talk about pedagogy as imagining being in an enchanted garden. And the garden is beautiful, has these very beautiful flowers, colored. The plants are luscious, and there are plaques in the garden with all the gardeners that have planted the gardens, the names of those gardeners. I see our field of education the same way. So many people have come before us, and whenever we as educators are visiting a garden, also known as professional development, such as this one, we're trying to take back a little bit from standing on the shoulders of giants, and also hopefully reflect on our own teaching, that when we go back to our garden and now that space has moved and become our classroom, we are taking back not just pedagogies and tools and tasks, but also hopefully the understanding that teaching is all about flexibility. With so many changes that have come in technology, with different viewpoints and different ways of thinking, um, education has cultivated some beautiful theories, and you may not agree with all completely, and you may take some with the under your wing and take it forward and make it your own. So the garden in that sense is then a metaphor for a space where the teacher is not just well versed with the pedagogical theories, but also someone who is understanding the importance of nurturing and how all plants grow differently. And we need flexibility and empathy and growth as educators to take back into our classrooms perpetually. So I will begin with something that, apart defining pedagogy, would be to take you into two main things, two terms that I use very often with math educators. When we are trying to build in our students something that I call math agility, there's something that comes in the way, which is known as the math divide. So what is math agility to begin with? Firstly, the understanding that we can break apart numbers. We can break apart quantities in different ways, multiple representations of that value. And also the understanding that big values are nothing but composed of smaller values, just like calculus is. When I'm studying calculus, I'm studying incremental changes. Also, math agility would be the ability to visualize relationships. Here I have a square, and here I have a cube with 6 faces, and all faces are squares. Math agility also comes with the ability to recognize patterns, to find optimal paths. What would be the best way to get from the red to the green square here? To decode data or anything numerically if possible, such as making this right now a simple equation here, 5 minus 4 or 5 minus 1, one car left the parking lot and we are left with 4. Analyzing data, of course, and trying to extract meaning out of numbers and thinking flexibly. So when we are expecting as teachers from our students math agility, what comes in the way is a math divide. And math divide, there's a lot of writing here. I'll kind of break it down in the form of a table, is the idea that students will not connect or pursue math when they lack language and vocab embedded in rich math talk, an engaging lesson, tools to absorb and assimilate information, problem-solving strategies, initiative to try and motivation to persevere, empathy, being kind to themselves and others, working memory and long-term memory skills, focus and retention skills, and the understanding that math is not about rules, speed, or getting the right answer, but finding optimal solutions to problems. which comes with logical reasoning, critical thinking, and of course, the proof that math enhances cognition, but also gives you the ability to decode, process, analyze, summarize, estimate, project, forecast, make predictions, and better decisions. And all of this also comes with the accessibility to math, which for very young children comes with solid number sense and math fact fluency. I'm not talking about procedural fluency right now. I'm talking about fact fluency, and I'll discuss that in detail. So the math divide and how to bridge this gap. When I spoke about language and vocab, in everything we begin as early as elementary to middle to high, our language and our vocab is very important. And that translates when you're talking about even as early as children are beginning to draw a line or write a letter, we talk about sleeping lines and standing lines and how that could be translated to math language. And we talk about horizontal versus vertical, and then transfer that knowledge to rows versus columns or a cross versus down, and then x-axis versus y-axis. So language and vocab in our classrooms and meaningful math talk is really important. Of course, an engaging lesson. And today I will be sharing with you a lot of tasks and routines that wow the students and hopefully you to take back to your classroom. Tools to assimilate, which would come with graphic organizers, which would mean ways in which you break down information with effective note-taking and you actually teach it explicitly to students. Problem-solving strategies, which will come with metacognition and very good questioning and reflection on your part on not just how do we do this and why do we do this, but a lot more meaning than what would happen if you change the variables, and who can tell me a better way to get to the result, who has a more efficient way of thinking about this, what happens if I change one of the quantities with something else. So problem solving strategies, initiative to try, which would mean using low floor and high ceiling tasks. I will give you an example of one shortly. Motivation to persevere will come with building a lot of growth mindset into the kids and showing how your own struggle as a math person and how you probably have not been a genius all your life and how you worked hard for what you have achieved in teaching, in your career. Working memory and long-term memory, focus and retention skills, which comes with good organization and games. Again, some of the games I'm going to be mentioning today, or some at least engaging tasks. Showing empathy, showing your human side, developing number sense in your children will all help in eradicating or at least eliminating the math divide. Having developing fact fluency, and building logical reasoning and embedding it in everything. And I will also be discussing that today. And getting your students to make decisions at some point throughout their journey as learners. You can give them some scenarios or case studies on what would you do if you encountered this situation. And let them build their own class norms or your class rules and procedures. Let them make their own quizzes. And that hopefully and more is going to be the bridge to bridging the math divide gap. So low floor, high ceiling. Here's an example of one. When we're talking about low floor, high ceiling, firstly, low floor is speaking to giving an accessible entry point to all learners in your classroom. High ceiling requires deeper exploration and challenge, and that will be catering to your students who want the challenge, who want to think above and beyond the accessible entry point. So here's a problem. You're organizing a pizza party for your classmates, and you have 3 pizza options to choose from. There's a regular pizza, there's a large pizza, there's an extra large pizza, and I've given the specifications for each, how many slices and what would be the diameter for each pizza. And some of the low floor questions would be like A and to an extent B, that if you order 4 regular pizzas, how many total slices of pizza will you have? And if you order 2 large pizzas, what is the total area of pizza you will get? So I'm going from elementary to middle and then hopefully to high. The extra large pizza cost 1,254 rupees. I'm using a whole number here. You can make it a decimal. Is it a better deal to order 2 extra large pizzas or 3 large pizzas in terms of price per slice? So when we break our task down in this manner, we are inviting more dialogue and more engagement from our students, which is going to get you to polish and make better the math agility and take away, hopefully divide the math divide. So the first pedagogy that has been proposed by NCF is the playway method. And a lot of times, a lot of educators look at this and say, well, I guess I understand the relevance for it, and I see how fun it might be, but I'm not sure I can use it beyond elementary. And the answer is no. There is so much to use in middle and high school, but it begins, of course, with elementary. It begins, of course, with play. Everything is play. So according to research, scientists have discovered that it takes approximately 400 repetitions to create a new synapse in the brain, unless it's done by play, in which case it takes only 10 to 20 repetitions. And repetition is important. There is something known as the forgetting curve. And we need to repeat, but we need to repeat it in a smart, in a sensible, in a multi-representative and a multi-sensory way, rather than the same way again and again. So it'll come, of course, the playway method will come with lower classes, with games, with manipulatives, with movement, with life and stories. For example, I see a lot of math right here. I'm looking at a situation where I'm looking at 10 flowers where I have 3 yellow and 7 blue. And I can make 4 equations from that with my fact family, 2 addition and 2 subtraction equations. So a lot of math in real life, a lot of math from stories from everyday life, some popsicle sticks talking about this number representing 22, and then adding another bundle of 10 and making that 32 versus taking away 1 stick and then making that 21. So of course, play does come from the lower classes, but as it progresses, you can build it into your middle school life with real life examples of using Cucumber to teach circles, and of course, stacking the circles to then go into the circles becoming cylinders, looking at 2D versus 3D, looking from the top versus looking from the side, making simple origami, then changing to more sophisticated origami and becoming nets for calculations, for surface area, and then eventually using it for perhaps volume. Building, of course, comes from the lower classes. These are tangrams here. And then the same tools can be used and modified in different ways. And I'm sharing some of those here. Create an animal using 7 two-dimensional shapes. Shapes may repeat, and this could be a drawing. If they're building it, it would be 3D. And then going on from tangrams to pattern blocks. By the way, all of these are available also virtually on many websites. Build a shape using 1 hexagon, 1 trapezium or trapezoid, 5 triangles, 1 rhombus, and let them see and see the magic and see the creativity there and the innovation. And then build more questions from there, such as what fraction of this shape is yellow? As we can see, there are 6 of these green triangles that are going to fit into this hexagon. Or build a shape that is 6/16 yellow, 5/16 green, 3/16 red, and remaining blue. And this is when we have a common denominator. And then you can progress to putting it in simplest form and then letting them see it as an equivalent fraction. So build a shape that is 3/8 yellow, 1/8 blue, 3/16 red, and remaining green. So much math is at play with playway, activity-based method. Here are unifix cubes, create a structure using 10 cubes, and then use the same structure to perhaps find the volume, or to even make it a question of elevation. Draw the top, front, and side view of the structure. So a lot of times when I was mentioning that, teachers would say that, okay, well, how do I use this now in a setting for a high school lesson? Any object can be taken, such as a water bottle, a textbook, or a chair. You can take outdoors, take your class there for measuring shadow lengths and their heights on a sunny day, and use that to teach trigonometric ratios or similar triangles. And after acquiring knowledge of trigonometric ratios through your beautiful lesson, use the same principle with student heights and their shadows to calculate the angle of elevation or depression. So for some of my teachers who are not familiar with the vocab here, just very quickly, I have what is the angle of elevation, what is the angle of depression. And then we progress into a second pedagogy that has been suggested by NCF, which is the discovery or the inquiry-based method, which will come from the playway, which will come from hands-on experiential learning, but will also come with a lot of investigation and questioning and critical thinking. For example, a measurement lesson can be very hands-on, getting the students to actually measure the length and width of their notebooks, of their textbooks, and then of course, they're using multiple senses, and they're using their visual, auditory, they're using their tactile, kinesthetic sense, but they're also using math here to be able to see and perform conversions, and using rulers and other measuring tapes to understand the unit better. Another example, of course, would be weight, again, a measurement lesson. How do I know? And now the questioning comes in. It's not just about playing, but you're asking some very meaningful questions. How do I know which side is heavier? Is there a way that I can find out? And discounting work for all objects, which is something how you segue a measurement lesson for very early children. They're very used to counting with fingers, then counting using place value. But beyond that, does counting work for all objects, or do some objects need to be measured? Can you arrange these objects, whichever ones you've taken from daily life, from heaviest to lightest without using a weighing scale? And then check if your predictions, your estimations, your eyeballing is matching the actual measurement. Why or why not? And what challenges did you face when you used the weighing scale? And how does the weighing scale help us accurately measure weight? Some other examples would be to, now moving into middle school, high school, is it possible to create a triangle with side lengths 3, 4, and 8 units? Let's try it out with toothpicks, with matchsticks, with popsicle sticks, with a spoon. Let's measure it and let's see if it's possible for me to create a triangle such as this one. And of course, through exploration, hopefully your students are the ones who are going to they won't know the name, but they will be able to, through this activity, explore the triangle inequality theorem. Is it possible to construct a triangle with 2 right angles? Let them draw it without any construction to begin with, or basic tools with the protractor. Is it possible to do so? And hopefully through this, again, they are getting to explore the angle sum property. Also, using play, using everyday life, I'm trying to show how sum of angles of a triangle is equal to 180. And I can show that again by cutting my angles and actually laying it in the form of a straight line, and also seeing that angles that's forming a linear pair, angles on a straight line. So that relationship between angle sum property and all angles on a straight line. After playway and discovery, another method that has been proposed is problem solving, and it's been around for so long, and we use it so often without giving our children the tools on how we are actually using it. When we read a word problem, when we are solving the word problem, we are going and making sense and extracting information, extracting numbers, extracting units. But a lot of times we don't show that process. We just start solving the question rather than showing the process of strategic thinking at play here. So, and there are so many different ways to problem solve. We sometimes are looking for a pattern. Sometimes we are putting the whole information in the form of a chart, making a table, a Venn diagram. We're trying to make it simpler. We're working backwards sometimes. We're using guess and check. We're using logical reasoning. We're using deduction. So a lot of these problem solving methods, and as I said, math, vocab, and language has to be introduced in the class for it to be used effectively. So elementary, and I would love to open the chat for this one, Tanisha. If any teachers want to participate. So here's problem solving at the earliest. If there are 6 oranges in a basket and you take out 4, how many oranges do you have? Or when does 9 plus 5 equal 2? Or how can you make this equation correct? 81 times 9 is equal to 801. So I am getting, now I saw in the chat, the first correct response to this, because language is so important. And so many times we hold our children responsible for not understanding the question when we have not given them tools to understand the question effectively. So if there are 6 oranges in a basket and you take out 4, did not ask how many are remaining. I'm asking how many oranges do you have? And now I'm seeing the chat filling up with people changing their responses from 2 to a 4. When does 9 plus 5 equal 2? And is it ever possible that a 9 and a 5 added to that could give me a 2? Pramila, you're right. I wanted to play around with this a lot more, but yes, thank you. Time. When it's at 9 o'clock and I add 5 hours, I'm going to be at 2 o'clock. How can you make this equation correct? 81 times 9 is equal to 801, which is at the moment not correct. Anyone? Tanisha, are you thinking about this one?
Participants,
all right. Yeah, we have participants. Pramila is on the spot here. Awesome job. That's right. Reverse it. Put it upside down, and then it probably becomes an equation worth looking at, which is 18 times 6 is 108. Some other creative ways to look at it. Then moving into middle school, which would be something along these lines, that here are some cubes, some dice, and I have the number 3 right here on the dice. But you can see the other numbers. I mean, the dice has been placed in different ways. Now I have moved all the dice from showing the number 3 on top to showing number 4 on top. Now, what are the spaces that I can fill out? What numbers would go in these empty spaces? It does not happen from just today we'll begin with problem solving. Every day into the culture of the school and the culture of the classroom, you need to build in problem solving for you to be able to see students who are actually thinking, who are using your inquiry-based learning effectively. And another example would be, and I've taken this from Mathagon, which is an adaptation from NCTM's problem. Mrs. G's geometry class is having a bake sale, and a whole cake is worth $10. You can change the currency. What is the price of each piece? Having cut it in different ways and creative ways. I like the fact that I'm still thinking about that question on dice. I would love to see the responses afterwards. And then this brings me to the next method, which is the inductive method. which is a logical approach to reasoning involving observation, looking for patterns, formulating a hypothesis or generalization, testing, and drawing conclusions. What would that look like? It'll again come from very effective questioning, but first showing your students a lot of patterns to look at and hopefully use those patterns to then formulate a hypothesis or a generalization. So what would that look like? With early years and elementary, something along these lines. What do you notice? What do you wonder? You're not giving any input on, here's a weighing scale, it shows 36 grams, there are 4 blocks. This is all evident. This is visible. This is visual. So rather than giving the question, give a question such as, what do you notice? What do you wonder? And then build from those questions. What's going to happen? What will the scale say if I add a 5th block? What if I remove 1 of the blocks? What if I remove 3 of the blocks? What do you notice? What do you wonder? And the same thing, as I said, can be built into middle and high school. What do you notice? What do you wonder? Do you see rhombuses or do you see cubes? What do you notice? What do you wonder? If we have any high school teachers, I would love to see their inputs on this one. You can type in the chat, anyone interested in giving us some insights on what do you notice, what do you wonder for this?
Participants, you can.
Thank you, Tanisha. All right, awesome. Thank you. 2 intersecting lines, that's right. Anything beyond that? Coordinates, great. The axis, the scale, awesome. 1 solution. Now I'm hearing some more high school teachers here. 2 triangles, okay. Those are lines going. I mean, I know it's cut out right now, but I can see how you can see 2 triangles there. I understand. What else? Anything about the lines? They are intersecting. That's right. Some linear equations. That's right. I actually want to direct your attention, even if you're not a high school teacher. Here's my x-axis. Here's my y-axis. I have my blue line, which is sloping downwards. I have my red line that's sloping upwards. And there is so much math in there. Now I'm hearing, yes, Bal, I see that. The y-intercept, the intersection point here happens to be also the y-intercept, which is where these lines are cutting the y-axis. And where is it cutting the y-axis? At the point 0, -5. And what's a relationship between these 2 lines? Actually, if we find the equation of the lines, which is also possible by the graph, using the intercept as well as the slope and putting it in y-intercept form, for example, we will be able to see that both the slopes have okay, thank you for noticing all those things. Both the slopes, the y-intercepts are the same, which is -5, but both the slopes are actually opposites. One is +3 for the red one, and one is -3. And that's also possible from the visual. And we don't play around with this a lot when we talk about slope. I'm trying to draw this here to show, let's say, a point right out here, which is -1, -2. If I look at this point and say this point, which is 0, -5, and make a right triangle out of that, I will be able to count the units that I'm going down versus across and actually see the slope. So if you can see is 1, 2, 3, 4, 5, 6 units as opposed to 2 units, but those were 6 units down. So that's -6 and that's 2. And that's my slope, -3 for this downward sloping line. Same thing can be shown here, but it's going to be positive slope. That'll be a 3. So what do you notice? What do you wonder? didn't ask any question, but so many questions and answers come out of that question. Moving forward, what comes next? Another beautiful task activity for inductive method, showing patterns, building patterns with the kids. These are unifix cubes. And then using the same tool for, say, middle or high when you're teaching sequences, arithmetic sequences. What comes next? 36 grams, 27 grams, 18 grams. What would that look like visually? What will the fifth one look like? What is it? Is it possible for that, the fifth one, to say a particular value here? So is that an infinite sequence? Is it finite? And as I said, using patterns to then build beyond those patterns a bigger conjecture. What will be if this is the first shape and I keep adding 4 squares here? Which pattern number will have 48 squares? And again, coming from just observation, just getting the students to make an X and Y table and to take it from there to get them to go from the term to term rule to the position to term rule. After the inductive method comes the deductive method. And I mean, it's not a linear scale that you use one and you don't use the other, or you use one and you use one in progression. Out of all the methods that I have mentioned, all of these, as I'm trying to show, and hopefully it resonates with everyone, you can begin from as early years, elementary, and move all the way to high school math with it and beyond. So deductive reasoning approach would look like the following. It'll have conclusions being drawn from premises. And this method is ideal for making sound logical arguments. So what would this look like? In deductive reasoning approach, conclusions are drawn from premises. And the method beautiful method that comes out of this is syllogism, which is there's a statement, which is a declarative sentence that expresses a fact. And there's a premise, which forms the basis of the argument. And then there's a conclusion that is hopefully the statement that you're aiming to prove or demonstrate, which is coming from the premise. It's drawn from the premise. Some examples of that and how that would look like in, say, middle school to high school. Premise 1, all squares are quadrilaterals. KIND is a square. Conclusion, therefore, KIND is a quadrilateral. Another one, premise 1, all integers are rational numbers. -7 is an integer. Therefore, -7 is a rational number. A lot of times, a lot of students have a lot of difficulty sometimes distinguishing between the two methods, inductive and deductive. They sound alike, and I get it. I've tried to differentiate with an example, a similar example, not exactly the same, but a similar example to the two. So inductive, Ms. J is teaching her students about shapes, and she presents them with a sequence of shapes and asks them to identify a pattern. She shows the students an equilateral triangle, then she shows them a square, then a pentagon, then she shows them a hexagon, and then she asks the students to observe the shapes and discuss what they notice about the sum of the interior angles. Finally, she introduces a heptagon, a 7-sided polygon, and asks the students to predict the sum of the interior angles based on the pattern they identified. That's inductive, where we are moving from specific observations to general conclusions, as opposed to deductive reasoning. And an example of that would look like the following. Ms. J is teaching her students about shapes. She explains that all squares have 4 sides of equal length. And she then shows them a shape with 4 sides of equal length and asks if that is a square. So some fundamental tools for all of these I have tried to share with the pedagogies that I have listed, which have been the playway method, problem solving, inductive, deductive reasoning, inquiry-based method. And at this point, I would love to hear from you as teachers and take the floor for questions on how we can use your challenges with using these methods, or how you use these methods in your classroom, and how we can all learn from your experiences on how to take it forward. I shared some pedagogies. There are so many more. And I would love to hear from you on which one's your best, or how you have employed any of these in your classrooms. Tanisha, I hope the chat is open.
Yes, ma'am.
Yeah. Specific to general, okay. Pramila, that would be the inductive. Known to unknown, primary children. One of the things that I usually notice that always comes to play when it comes with primary is that very soon we move away from those kinesthetic materials to pure math on paper, writing. And then it goes very quickly from showing addition is, for example, collective, the collective sum, to going to very high problems, very high numbers, and not building in something, say, what is 7 plus 8 in a more efficient way. So I would love to share some ideas on how to make that more effective. I will be showing that shortly. Problem solving, hands-on activity, awesome, great. So I usually have this question from primary teachers. What do I do with something along the lines of 7 plus 8, or any of building fact fluency when I was talking about numbers, number sense, and fact fluency? So we, of course, and you ask this question to any student, a young student, and if they've not memorized the answer, it's always like 8, 9, 10, and then adding and then getting to the sum. Well, if we solidify partners of 10 in our students, which is to be able to look at what numbers would make up 10, that's a 10 frame. So 8 needs what to become a 10? I need 2 more. That means to balance this, I need to take 2 away from the 7 and make that a 5 to be able to see that sum to be 15. When they look at a fast 10, such as this one, 10 plus 5, 90 plus 9, 60 plus 5, it's easier for them to work with the question as opposed to giving them something like that. So this transference and this decomposition and this regrouping is something that needs to be taught more often, I think, in primary than jumping to higher numbers, and not solidifying partners of 10, partners of 20 will always come back in ways to bite us as teachers. I think I have some other ideas. Okay, all right, great. Hands-on activities and problem-solving methods. I'm hoping that I have shared some from my end. I would be happy to share more as we progress. If there's more exploration required, I am available on social media, and I'll be happy to share more ideas. All right. Tanisha, I'm leaving the floor open. I think people have sat through a lot of these webinars today. So I'm actually leaving it open for questions and an interaction more than giving them more and more tools today. I think everybody has reached a saturation point as well.
Great. Participants, if you have any questions or queries, you can post it in the chat box. Ms. Pratibha has asked, how can multiplication tables be learned? Is there an easier way for them to learn?
Yes, absolutely. A lot of times, again, as I said, sometimes the way something is taught is always, there was a time, and Peter spoke about this in the first session. Um, we've gone from a conformist classroom to now hopefully a thinking classroom. That is the need of the hour. Um, we were training our students to work in factories at one point, but that is not the case anymore. So the tools and of course memorization for singing a music note or something is great, but if it's not understood on what is really happening when you're doing 4 times 5, and they don't see it visually, they don't play around with it, it is going to be detrimental to the students and us eventually, because multiplication will be needed in division, which will be needed in fractions and decimals, which will be needed eventually for percentages, which will be needed eventually for high school math. So there's so much connect there. Here are some ways in which I usually introduce multiplication. I do not always start with just here are the tables. Firstly, the idea that multiplication is nothing but repeated addition. So, is there a better way to do this? Can I do this in a little different way? And that's when I again don't introduce multiplication or the times sign at the moment as a symbol. I just go by making uh, how many are these? 5 groups of 3 to be able to first count and then take it from there to make this a question, which actually going onto a grid is the same as saying 5 groups of 3. So what does 5 groups of 3 look like? How can I draw that? Can I make it as 5 rows and 3 columns, or should I put it as 3 rows and 5 columns? Is it the same basically? Is that commutative property? And from those visuals, I get on and introduce my multiplication, which is where I would say that a better efficient way to talk about this would be the following. And building and not just showing this, building this on a regular basis. When you introduce one table, might as well get them to build it on grid paper and be able to see the 3 times 4, the 3 times 5, the 3 times 6, and how every time I'm just adding a 3 or taking away a 3 if I'm going backwards. So multiple representations and multi-sensory learning is something that I am a big proponent of when it comes to primary maths, rather than just starting with multiplication tables and then asking the kids to memorize one per day and come back. Not productive, and it will not be useful in the long run at all. Any other questions? Tanisha, I'm finding it hard to keep up with this
The
chat. Please go ahead.
chat box is, yeah, it's filled with so many appreciation messages, so it's just hard to find a question. Okay,
I
yeah,
think
so there's one, how to inculcate basics in higher classes like ninth and 10th, and which method would be beneficial for that?
all of the methods, Umang, hopefully you took away some of these for the high school students. But I will definitely say, and something I say to my teachers, um, we know of the old adage that Rome is not built in one day, and it's sometimes hard. The age group you're talking about, there are too many other distractions coming into their life at that point. So of course, the best that you can do is first help them navigate, uh, be a resource person for them, that they look up to you as a teacher. But of course, it is too much responsibility to take for only ninth and 10th grade teachers to uh, you know um, build on. We need the support of primary, we need the support of middle school teachers to have had very strong number sense, fact fluency in our students inculcated, so that you can take it forward. You can get them to see the applications above and beyond the procedural facts, and how do we use it and apply it in life. Discussed problem solving methods. I think the problem solving method, and you can Google this, by George Polya. A lot of people use different mnemonics to help you remember the problem solving strategies, but the problem solving plan really, whenever there's a word problem and how do you go about solving the problem. I think if you aid your students in the problem solving method, that would be of foremost importance to the children on how they can decode a problem and break it into math. And then it becomes easy. Then the from that point on, solving is not the problem here. It's the problem itself, and what do you do with so much data, and how do you read it, and how do you make sense of it, and how do you extract the extraneous information versus what is really important. And then what procedure is needed to solve is secondary, but how do you use your metacognition as a teacher to question and scaffold the students to really be able to maneuver through a problem given to them. I think that would be a beneficial method, the problem solving method. But all of them, deductive reasoning, inductive, play way, I hope the students don't lose play in their lives when they come to high school. And if you don't have enough manipulatives, please reach out. There is enough on the web when it comes to Desmus, GeoGebra, Mathagon, where you're already using anything that was hard or not portable has now been made virtual. So using graphing calculators to be able to show the graph visually, to be able to show the turning points, if you're doing calculus, to be able to show that this is an increasing or decreasing function, visual is the best way to go about it. So hopefully if they're not seeing it in concrete form, they're seeing it in pictorial and abstract form um, in 9th, 10th, 11th, 12th grade.
Great. There's one more question regarding the word problem. Like children face problems while doing this, so how to help them in a better way?
I think I'm on the same question. This is Shweta, and this could be anybody's question. Um, it does not come from, there's no magic solution. It comes from first versing them with really good language and vocab, which will come with asking questions above and beyond the textbook, and looking for more material and curriculum that is beyond asking them 3 plus 5, 5 plus 9, but to be able to actually apply it. I'll give you an example. Yesterday, I was speaking to a teacher from 3rd grade, and she was talking about using subtraction word problems in her class. And most of the problems that I saw framed in the textbook were along the lines of so and so had this much money, and then she spent this much money, and now what is left, what is remaining, what is left, what is remaining. I see the same language, and I try to give more ideas on how to ask this differently. It could be height. Two people have a certain height. Who is how much taller than the other? So you're asking it in more in a way that is above and beyond the basic, and going one step extra when it comes to vocab and language yourself. Asking, there were so many people on a train platform, and these many number of people took the train. How many are still at the platform? You're not using any math word here, but they're just using language to understand what's remaining, what's gone, how many have left the building. So it comes from an early age, developing strong language and vocab in the students. And then it comes from problem solving on a regular basis, giving them a word problem every day, which may not be related to the textbook. And there are so many on the art of problem solving. There are so many websites that give you so many resources and question banks to these. And just getting students to play around with numbers, and initially, as I said, with manipulatives, and you asking creative questions from the children. How can we build this differently? How can I use 10 blocks and make a different figure out of it? Once you activate that language part, then word problems are easy. But if they see math and language as two separate subjects, which they're not, then there will be a problem, because sometimes a lot of students see math as just numbers or like sums or questions, as opposed to seeing math as a problem, and mathematics as a tool for problem solving. So it needs to be built in. It will not happen instantaneously. but it is possible with good questioning.
Great. So there's one more. Any tricks to explain for slow learners?
Patience for any student, any student. Not everybody gets something right away. You are fortunate to have some students who get it right away because their parents, their tutors, somebody has made some connections in their brain that they are coming to you ready with some prior knowledge. It's actually the slow learners are your best learners because you have them from scratch. It's your responsibility and the ball is in your court as a teacher then to actually activate and build in them some knowledge that they'll be able to make those connections. And I say this with due respect to the work we teachers do, but honestly, our best students are actually a work of their parents and their households. We are just taking it one step forward as teachers. Of course, good teaching makes a big difference, but it comes from first teaching social emotional learning, good language skills, and reading fluency. If reading fluency is not there, if we don't have focus, if we don't have working memory or long-term memory retention skills, it's hard. I get it, but then it comes with patience and it comes with developing those skills first, those executive functioning skills first, before you handle the math. But it goes hand in hand. It cannot be an isolated affair.
Okay, thank you, ma'am. We'll take just one more question. How
Sure.
to teach factorizations?
So, depending on the grade, first it would just come with elementary, and I will progress to middle to high. And I have to see time here. But starting with elementary, it would mean just understanding that any product, firstly, if I am able to, if it is not a prime number, then I am able to come up with some numbers that I can multiply to a pair that will give me that product. So this is my product or my multiple, and these are my factors. From there, you progress into middle school, for example, let's say with a numerical example, and then going into abstract. From that point onwards, when it comes to high school and it comes to once the prime factorization is very solid in middle school, then with high school, I have some beautiful tools and I would love to take it on at another PD, Tanisha. You have ideas there for factorization beyond middle school.
Okay, thank you so much, ma'am. So I think it's time now. Thank you so much for your enlightening presentation on the suggested pedagogies for teaching mathematics as per NCF 2023. Your expertise promises to be an invaluable resource for our educators. And we would also like to thank all the participants for joining today. I'm sure you found the session informative and helpful. I mean, the chat box was filled with appreciation. And so, yeah, we are ending day one sessions. On this note, wish you all a good day ahead. Our day two sessions are slated for tomorrow, August 26th. Please stay connected with us for another day filled with insightful discussions on various aspects of mathematics. See you all at 10 a.m. tomorrow. And remember that we have an exciting lucky draw and quiz planned, offering you the opportunity to win Amazon vouchers worth up to 40,000. So don't miss it. Thank you so much, ma'am, once again for this amazing session. It was great
Thank you
having
so
you with
much.
us.
Thank